Day today, I'm an executive search consultant. I'd like to welcome our guests today, which is Branden Chan, ML engineer at deepset.ai, Paul Walsh, analytics and AI senior manager at Accenture Ireland, and we have Yizel Vizcarra, senior data scientist at Autodesk San Francisco. We will be having questions, but we're going to have them at the end. I am the Chief Customer Officer at Alldus International, as I mentioned before. I'm going to give you a little bit of an overview about our meetup and also a little bit more about some of the community initiatives Alldus does day to day. So Alldus is a recruitment company specializing in AI, data science, and cloud. We cover Berlin and Europe from our Dublin office, and we also cover the East Coast America from our New York office. So all this was created with the goal of a move forward in artificial intelligence. And when we look to do that, we wanted to be very collaborative, add a lot of community initiatives into the marketplace too. So all this ambition, we're listeners, we're learners, we drive, we're unified, and we're specialists. And consultants that work on the roles day to day and engage with customers or candidates, we hope this comes across in your interactions. So as I mentioned before, we've got an offices in Brooklyn and also in Smithfield. And before COVID, we were doing regular in-person meetings in Berlin and Dublin, and we're soon to have our first offering in New York. But since COVID, we've had everything on virtual, and we've been running meetups in AI and healthcare, our NLP series, and computer vision series. Today, to give you a little bit of an overview of the breakdown of our members in Dublin and Berlin, we also have over 7,000 attendees in person, and that's probably amplified significantly through our virtual meetup series. We've had over 40 events, and we've had over 100 plus speakers from the world of artificial intelligence. We run two podcast series. One is called AI in Action, and the other is called AI Mentors. In AI in Action, it's the applications, implications, and ramifications of AI, but really what it comes down to is how do you solve business studies problems by applying machine learning to them. So guests come on, represent their companies, and talk about some of the business problems that they solve by applying machine learning and giving some real return on investment minus the hype. With AI Mentors, we talk about how to build out a data science, data analytics team, the journey to actually getting a return on investment from that. The very nature of working in machine learning and AI is that there's significant amount of research. So to actually look at the research, you can probably fall down several rabbit holes as a data science consultant. So what we look to do is talk about advice, the journey to now, the importance of having an MVP, getting some type of POC ready, and then shipping it, iterating, and working with different stakeholders day to day. We have over 150 guests, stories on AI in Action, AI Mentors combined, and it's now one of the most listened podcasts within artificial intelligence around the world, according to iTunes. So within our day-to-day, it's in artificial intelligence, data science, and cloud recruitment. And we're very proud that we change people's lives in terms of the projects we give people for their new work that they have, and also for customers that when they take on people, the work that they work on, some of these applications come to market that's moving AI forward. We're very proud of the fact that we have over 250 five-star Google reviews, which is one of the most trusted recruitment agencies in the world. So if you're interested in the world of getting a job or moving on or just finding out more about data science and AI, we've got a career section dedicated to that area with over 70 posts that talk about applications in this area, getting your interview correct, making sure to share relevant STAR approach when you're actually looking to conduct an interview, and also some specific advice to data scientists who want to go into certain areas such as NLP and computer vision. We've guest posts on from different people coming on, offering their advice to hiring and also advice that they'd offer to their younger self if they were to go back and start their journey again as well. So we try to keep the posts between 1 to 3 minutes in duration and make them very easy for people to engage on as well. If there's any other posts or information you'd like to receive, please feel free to reach out to me at mark@alldus.com. But there's also a jobs@alldus.com as well, where you can sign up for regular jobs updates too. Here's an idea of some of the jobs that we currently have at the moment to give you some perspective of them. But if you've got a good profile, you're just interested in the market in general, please feel free to reach out to any of the consultants with our European or our US-based offices. And without further ado, that's myself done. I'm going to pass this on to Branden Chan, ML engineer at deepset.ai. I'm going to give a bit of an overview about Branden's talk today. So the title is Neural Search, Scaling QA to Thousands of Documents. With recent advances in transfer learning, the performance of question answering models reached new heights and suddenly created a new class of industrial search applications. In this talk, Branden will explain how to fine-tune a transformer model for the task of extractive question answering and how to scale it to thousands of documents, open domain QA. In addition to recent insights from research, he'll share practical tips on how to implement state-of-the-art systems yourself using open source frameworks. Branden, I'm just going to close off my slides now and should be able to let you present.
Excellent. Yes, thanks very much, Mark and Liam, for having me here today. I'm very happy to talk to you all about exactly what he mentioned there, scaling question answering. Hopefully I can get my slides going here. Is that showing up?
Yes, I can see it perfectly well.
Excellent, excellent. And let's get into it. Yeah, what I want to talk about is scaling QA to multiple documents. So as I mentioned, yeah, anyone who's in the field of NLP or deep learning has probably heard about new innovations, models like BERT, and the increases in performance in tasks like question answering. What I really want to talk about is how can we make this work for people or for enterprises who want to implement this new generation of neural search. To just give a little bit of background as to deepset, where I'm working and what we're working on. deepset is positioned quite uniquely in the middle of research and industry. We see that, that there is quite a surge in deep learning-based NLP happening. As I mentioned, there's a lot going on in the world of transfer learning. There's a lot of new language models coming out, which are constantly pushing state-of-the-art performance. And there's a lot of focus on this task of question answering. On the right, we see that, yeah, deepset has a lot of experience working with partners in industries and big corporates who have large stores of documents. And we've really seen that a lot of them have this shared need for being able to work with their large repositories of text in intelligent ways and in fast, efficient ways as well. And that's really brought us to focus on our latest open source software. It's Haystack. And I'm going to be talking more about that. It's an industrial neural search system. It's driven by question answering and it's open source. And we have a layer of enterprise features on top of that. I can talk about what is actually included in Haystack in more detail a little bit later in this talk. But to start off, I kind of want to build up from the ground up, what exactly do we mean by an industrial neural search system? So we can actually start off by seeing what is possible with Haystack. And I'm going to quickly switch to presenting the demo. But just bear with me 1 second. Stack demo. How's that? Can you see this search bar, the ask a question and deepset? Is that coming up? Sorry, I can't hear you right now. I think you guys are on mute.
Yes.
Okay, awesome, awesome. Yes, so yeah, here we have a demo system which shows Haystack in action. What can you do with a system that is built on Haystack? Well, in here, in the back end, we have indexed, or we've stored a large collection of documents about the company NVIDIA. And perhaps we have a question in mind. Maybe there's some factor that we're looking for. And we might want to search through these documents, and we might just ask something in pretty plain English, like, how high was revenue in 2019? And here we engage the full system, and we're getting responses talking about expectations of revenue, revenue increases, and yeah, the statement of revenue from different documents here. Each one of these, here we see kind of the title of the document, the context in which the context of the question, sorry, a little snippet of the passage from which the answer comes from. And yeah, it's a measure of how confident the model is that this is the kind of answer that you're looking for. We can try this again with a slightly different question. We can look for something quite maybe open-ended, like how is the outlook? And once again, we're engaging this full system to read through the text. And yeah, we can see some statements from, for example, here from the fourth quarter document stating that we fully expect to return to sustained growth. Our visibility remains relatively low. NVIDIA's outlook for the first quarter of fiscal 2020 is as follows. So you can see, yeah, it's really parsing this question that we're putting in, trying to make some sense of that, and looking not just for phrases, but potentially sentences that give a proper answer. So let's switch back to the slides now. Yep. Okay. So back to the slides here. Yeah, that's what's possible with a system that is based on Haystack. So let's build this up from the ground up. We're going to talk about a different layers that build up these sorts of systems. So the very fundamentals level, we have language models, which really power Haystack. On top of this, we might want to be a little bit more specific and say we want to use these language models for the task of question answering. This is, yeah, the really core functionality that lets a model extract that snippet that we're looking for that answers the question. And then in a third section, we want to talk about how do we make this actually work in an industrial setting? What if you have thousands of documents? What if you have millions of documents? How do we scale this system to work in a practical way? So I'm not going to go into too much detail about the exact sort of how, like, the nuts and bolts of a language model. But I think for many people who are working in vision or in NLP, in this world of deep learning, they're probably quite familiar with this transfer learning workflow. And it looks something like this. In NLP, you would start with some sort of language model architecture. For example, something like BERT or XLNet or Roberta. And you want to train this so that it understands language generally. It gets an understanding of like what words mean, how they interact with each other, how sentences are formed. And to do this, you would first feed it an unlabeled text corpus. So maybe you've scraped a lot of text from the internet, or maybe you have all of Wikipedia. You would pass this to the language model, which would then become trained. And now you have something which has this general understanding of language. The next step here, if you want to train it to do something a little bit more specific, is to put something on top known as a prediction head. And once we have the appropriate prediction head, we can pass in something like a question answering data set. And by doing this, the weights in the language model and in the prediction head will get trained. The language model outputs vectors, which represent the input text, the text that's coming through. Those are passed on to the prediction head, which makes final predictions. And based on how right or wrong it is, it will adjust its weight until it becomes trained for the task of question answering. And yeah, what we're left with there is a trained question answering system. So let's talk about this task of question answering. It's made popular by a dataset known as Squad, which some of you might have come across. But it goes something like this. And when I talk about question answering, I'm actually talking about a specific flavor of it known as extractive question answering, which is finding the answer span in a single passage. So let's say we have a question. What is Berlin? And we supply the system also a single document or a single passage here. And here we have the first paragraph from a Wikipedia page about Berlin. So we ask, what is Berlin? And it's the job of this system to extract the span which answers this question. It's the largest city of Germany. So this is a pretty tough task, but models are actually surprisingly good at it right now. But yeah, there are a couple of challenges in building these systems, which is that for every question passage pair, a model has to take into account the interaction of text and question. If you ask a different question here, the model has to totally change up its strategy for picking the right span. There's a very large set of potential predictions. Any span in this passage is a potential prediction. So any system that you build has to be able to pick from a huge number of potential candidates. Also, a good model has to understand text that's potentially very, very long and understand it in context. So yeah, an understanding of a single sentence sometimes is clarified when you take into account what comes in before or after. That's what we mean by this contextual understanding. The popular approach to tackling this task is to train a reader model. This is also the same as what I described before as the question answering model. But the reader model is the terminology used when we kind of talk about the bigger pipeline. It'll become a little bit clearer in the next slides. But what we want to do here is train this reader model to identify a start and an end to an answer span. To do this is by, yeah, we basically go through that workflow that we showed before. What we want is to fine-tune a trained language model on a set of labeled question-answer pairs. And yes, Squad, which is a Stanford question-answering dataset, has become somewhat of a default dataset. That's not to say that there aren't other datasets out there, though. So Squad is hugely influential. It started off with Squad version 1. They moved on to version 2, which included these no-answer examples, so cases where the question couldn't be answered by a given passage. And there's been an explosion of other datasets around it now. So there are datasets which, starting from the left, there are datasets which have different structure. They include visual data as well, so they have images, and you might want to ask questions about the image. There are datasets which require multi-hop reasoning. So the idea is that it sort of needs to synthesize different pieces of information from different parts of the passage or from different documents even in order to come to a final answer. Down the bottom, you see actually there are a lot of variants that are in languages other than English. NLP is not just about English. There's need for question answering systems in any other language. Yeah, so now we have a Korean Squad, we have a Spare Quad, which is the Russian version of Squad. This is F Quad, which is the French version. And there are data sets which actually gather together question answer pairs in many different languages. There's Tidy, which explicitly tries to gather together languages that have very different structures. And there's XQuad and MLQA, which are very useful evaluation data sets for multilingual systems. On the right, we talk about open domain data sets here, which are really trying to push the scale at which we're doing question answering systems. Some of these kind of have their roots more in the information retrieval side of things. So yeah, if you have a collection of thousands, if not millions of documents, how do you pick out the right document that is being asked for? And the last one I want to talk about is the one in the top right. It's this dataset natural questions, which actually includes yes/no answers, which are, yeah, Squad actually isn't very well suited to being asked something like, is it true that something or other? Because it's always trying to extract a span from your passage, and sometimes you need a system that can just respond with yes or no. So natural questions provides that. So why are we so interested in question answering, and why now? Now is actually a very interesting time to be working in this area. So the popularity of transformer models and the success that people have found with transformer models has actually translated into performance boosts in question answering. It's really gotten to a point where actually it's very practical to use these models now in real world situations to perform question answering and at scale. Actually, yeah, I want to have a look at I want to show you this diagram on the right. I want to point to that, which is actually showing state-of-the-art performance on the Squad dataset from about early 2018 up until now. And there's a big boost that happens in between sort of the July 18 and the January 19 markers. And this is really, it's BERT. You can see these points in there for this BERT model, which is the first model that really made NLP using transformers successful. And since then, we've been steadily improving to a point where actually the best systems now outperform the human benchmark. And yeah, this has really spurred a lot of momentum in research, and it's gotten a lot of people very interested in this task, and have been trying to push this task in different ways. So there are people working on new models which will perform this task better, but also people who are creating models that sort of approach it in slightly different ways, that try to perform a little bit more reasoning or synthesis. There's a lot of research being put into making models that are more efficient. So this idea of distillation is to preserve performance, but to shrink the size of these models. And pruning works towards the same goal as well. Sparse attention is really trying to change the architecture of these transformers, trying to make them scale better as your input lengths, as your input documents become longer. That's really one of the weaknesses of transformers, which is that they have this quadratic complexity, and there's a lot of look into new attention patterns, which can really reduce that kind of complexity. And there's also a lot of work in getting QA to happen in languages other than English. As I said, there are data sets out there which can handle, which provide examples that are in Korean or in French or in Italian. And there are people working on models which are really trying to perform as well as they can on these data sets. And what we've seen from working with industry partners is actually that there's a lot of need for these sorts of for this task to be performed in a in any kind of company, actually. So there's a growing number of people who need to find answers to their queries, and right now this is done in fairly naive ways, either just kind of navigating through a stack of documents or through some very basic search tools. Sometimes, yeah, often these tools are very much keyword based, and in some ways quite a shallow kind of search. And we see that there's this need for a much smarter kind of search, which really parses full sentences in real language and can quickly search through a large stack of documents. And yeah, we really see that the web search has really come in leaps and bounds. That like it might not seem like it day to day, because I think we're also reliant on these systems, but it's quite a recent advancement that, for example, with Google now, when you type in a question, it doesn't just return a document, but often it will actually even highlight the passage within that web page, which gives you an answer to your question. And that's really what this gap that we're trying to close as DeepSet. We're trying to bring together the experience between web search and enterprise search, bring them much closer, and give everyone the power to build a system which really accurately answers questions. We also want to mention that actually question answering is quite a flexible field. We see this being used in a lot of different ways. And I think, if you're ever interested and want to dig into Haystack, we have that set up in a way that you can actually really use it for a lot of different use cases. So I want to talk next about scaling question answering to open domain. So we already kind of set up what question answering as a task looks like. You have a question, you have a single passage, and you want to extract an answer. But what if you have a question and you have a large collection of documents and you want to extract this answer? So there are a new set of challenges that arise when you want to do it at this kind of scale. One of them is that these reader models that we're talking about, which are transformer-based, are limited in the amount of text that you can pass into them at one time. They're limited in their input length. That means that it's tricky to get a very fast system that's just based on these reader models. That can be a bottleneck if it's not accurate, if it's not appropriately dealt with. And also there's this problem of what we call aggregation, which is that you have a lot of different documents and you might have a candidate answer in each. You have to pick the right answer out of all these candidates. So how do you pick that best one? And one popular approach is something known as the retriever-reader pipeline. And the idea behind this is that you start with the document store, which has all your documents. You have this next retriever component, which is, you can think of as sort of a quick filter to quickly remove the documents which just aren't relevant. You pass on a set of candidate best documents, and that is what's processed with this much more powerful but much more intensive reader model until you finally get an answer at the end. What we found was that if you applied this reader model by itself to about 7.5 thousand documents from the natural questions dataset, querying could take something like 3 hours or more. But once you put in this retriever, this filter, you can actually reduce that down to something like 0.5 to 2 seconds with very little decrease in accuracy. So yeah, I just want to have a quick mention of some of the best components that are available for both this retriever and reader stage in the pipeline. In our retriever, there are quite a few different models out there that I think are worth looking at. So just as a baseline, we talk about BM25, which is a keyword-based search system that's implemented in Elasticsearch, which gets somewhere around 60%. There was the latent retrieval via ICT paper that has this training using the inverse close task. That gets a little bit over 60, and approaching sort of the 80% we get to Realm and DPR, which is actually something that I want to talk in a little bit more depth about. DPR, we see actually a lot of potential there for improving the best retrievers out there. So the idea behind DPR is that for each question that comes in, we're going to process that using a transformer model like a BERT and get an embedding. We're also going to embed all of our passages into a vector. And then to figure out whether a passage is relevant for a question, we simply take the dot product of these two. There are a lot of training tricks that they use in order to optimize the performance. I think I won't go into too much depth about that, but to give a sense of how you might use this in inference, we basically can pre-compute a lot of these embeddings, especially for passage. We can index them to a document, to a store that specializes in vector similarity, like FICE, and then we want to retrieve the k nearest neighbors. On the reader side of things, we're basically talking about state-of-the-art transformer models, and there are a lot of them out there, and there are different trade-offs between size and performance and speed. But these are the ones that we're very interested in. In pure performance, Albert XL is the best one that we've seen right now. Roberta Base is a very kind of reasonable middle ground. And Mini LM is this one which actually is a distilled model, which is far more efficient in terms of speed than Roberta, but actually retains a lot of that performance. So yeah, I prepared a slide here talking about Mini LM, talking about how they've managed to distill a much more performant model into something that's much smaller, much quicker, but that still retains its performance. I won't actually go in detail through this slide, but if anyone has an interest in this, please feel free to ask me. I'd be more than happy to explain the mechanism they use and why this method works. Yeah, and the final thing I want to mention, as I said, we at DeepSet have been working very hard on our open source framework, which is Haystack. It's geared towards industrial neural search, and it has a variety of readers, retrievers, document stores, and you can also work with it. We have a Docker for deployment, and we have a REST API so that you can call it. Here's just a code snippet on the left that talks a lot, which shows you a full working QA system, full working open domain QA system. And you can see there highlighted a few of these concepts that we've already been talking about. You have your document store, you have a retriever, you have a reader. They're glued together using something called a finder. And already with those components, you can start trying to get predictions, trying to get the answers to your questions. And so, as for document stores, we have support for Elasticsearch, for FICE, for SQL. You can simply just do it in memory. On the retriever side, we have BM25, we have TF-IDF, which are these keyword-based baselines. We have also dense passage retrieval, which I was talking about just now, and also embedding retrieval, which is just simply providing your own model that will embed questions or passages. For the reader, we have all those models that we showed in that graph before. And what I really want to stress here is that we have an integration with the Hugging Face Transformers Model Hub. So you can actually just download any of those. And as I mentioned also, yeah, we have a REST API, we have Docker images that you can work with, and we also have a labeling tool for you to generate your own question answering label pairs if you want to fine tune your model more. Yeah, so just to summarize, language models form the core of most modern NLP systems. These language models are what have been powering question answering systems, which have recently become a lot more powerful. And using these QA systems, you can scale so that you can start performing QA in an open domain setting and start really like using this in an enterprise, in a real use case, in a real actual information seeking task. And if you want to build this kind of system, then I'd really encourage you to check out our own end-to-end open domain QA system, Haystack. We've been putting a lot of effort into it, and it's reflecting kind of, we're here to sort of bringing in the best of the research so that you can start using it already. And with that, I want to say thank you very much for listening.
Branden, thank you very much for that. That was fantastic. That was really, really helpful. I'm sure there's going to be several questions at the end to follow up on that as well. Thank you.
Great.
So our next speaker is Paul Walsh, Analytics and AI Senior Manager at Accenture Ireland. And his talk will be how he won Kaggle's COVID-19 challenges. How he won Kaggle's COVID-19 challenges and the relevant factors. So just for people that don't know, the DOC is Accenture's Global Innovation Centre headquartered in Dublin, where we assemble teams of researchers to help answer critical questions in the Kaggle COVID-19 data science competition. In this talk, Paul will outline how they approached the problem and use NLP and text mining techniques to develop world-beating solutions for automatically answering critical WHO questions on the pandemic. Strategic and technical details will provide along with sample code and publicity available notebooks. Paul, this is a fascinating area. I think we could probably have a specific virtual meetup series every day of the month on the area of this. So it's something that we're all really interested in hearing in more details about. Are your slides okay to share now? I know we're having a few gremlins.
There's a few gremlins, but Liam got me there. So can you see my screen?
Yes, I can see it. I can see it perfectly now, Paul. I presume everyone else is good. Sorry, it's loading at the moment. That looks really good to me from what I can see. I'm just going to ask Liam. I'm going to see if I can get a thumbs up. I got a thumbs up from Liam, so I'm going to get off the video now and let you crack on, Paul.
Great, thanks for inviting me along to this, Mark, and thanks, Liam, for getting rid of all the gremlins there. So, hi everybody, and many thanks for taking the time to listen. So I'm going to talk today about NLP at Accenture, the DOC, specifically what we did for the Kaggle COVID-19 competition, which is obviously very topical. A little bit about myself first. So I'm a senior manager with Accenture based in the DOC in Dublin. And you'll see a lovely picture of the DOC taken in better days when it was busy and full of all of the researchers. It's quite empty now, but it still exists as an entity where basically it's a meeting place. It's Accenture's Global Innovation Hub headquartered in Dublin, but we're now working virtually to help solve a range of problems for business and society. And, a significant part of that is the use of NLP. So, just a little bit about the DOC to give you some context. So, Accenture is a very big company. There's over 500,000 employees, would you believe, in Accenture. But, a big part of Accenture culture is innovation. And with that in mind, there's an innovation centre called the DOC in Dublin, where over 250 people work together to solve problems. And they're multidisciplinary teams working in the DOC from a range of backgrounds. Of course, we have technology and engineering helping us to engineer and scale out solutions and support with DevOps and enablement. We have research labs as well who are at the forefront of various topics in AI and machine learning. We have a human insights lab, which is really looking at the humanity side of the equation, where we're making sure that the solutions we develop will benefit people. So there's a lot of people working on that side. The other aspects of the team, the doc, are the co-creation incubation team, where they will get in clients and we'll work very closely hand in hand with clients to make sure that the solutions we're developing are fit for purpose and are solving real problems. We also have Fjord Design, which is a famous design agency helping to design, and that includes designing intelligent solutions as well. And of course, last but not least, is the analytics and artificial intelligence team, of which I'm part of, where we solve a whole range of problems for clients and a whole range of industries. So to the meat of the matter, which is today's talk, is the work we did for Kaggle's COVID-19 data science competition. And of course, we're all familiar with this character, which is the coronavirus, and known for its crown, so to speak, of spikes there that you can see in the animation, which make it highly infectious to humans. And of course, we know the consequences of the last 9 or 10 months of what it's done to societies around the world. So the thing that we can do to try and address the coronavirus problem is, of course, fundamental research into the biology of the virus and look for medical and clinical solutions and drugs and vaccines that can help solve this problem. So really, there's a lot of research scientists around the world working and studying these viruses to make sure that we can find a solution, understand the dynamics of the virus as well in terms of its epidemiology and how it's transmitted, and factors that give risks to people for various outcomes, such as comorbidities, such as hypertension and things like that. So you'll have seen in the media lots of different angles on this, that people of a certain demographic, older people are more vulnerable, people with comorbidities are more vulnerable, but also the spread and transmission of the coronavirus. As we all know, it's highly contagious, and face masks are a big issue, social distancing. So really, there's a whole huge raft of research going on, produced by literally tens of thousands of researchers around the world. So people are studying this extensively, and what they're doing is producing results in the form of scientific papers. Now, there's so many people working on this that it's very hard in many cases to get a consensus of what is actually going on in terms of the virus and how to control its spread. And essentially, what it boils down to is something that interests us as NLP practitioners. It's really kind of a text and natural language understanding problem. So with many thousands of researchers producing these documents, how can we develop systems that aid them in combing through these papers, extracting results that are relevant to the questions of interest? So that's really the challenge. So with that in mind, there was a competition launched earlier in this year, around April, to see could we assist researchers around the world in answering key questions related to COVID. And that's known as the COVID-19 competition, and it was sponsored by the White House and a coalition of research groups such as, the Allen Institute of AI is quite a prominent research group in AI, Center for Emerging Technology in Washington, Microsoft, Facebook, IBM, and many others came together to curate a data set of papers and pose a challenge to researchers around the world to help answer questions pertaining to COVID-19. And these questions actually would come from the World Health Organization. They posed roughly around 20 different research questions that they wanted us to help answer by mining the text within these scientific papers. So in Accenture, we decided to tackle this, and we formed teams. So we kind of got together and reviewed the questions that the World Health Organization wanted answers to. And we decided to focus on a number of areas, particularly risk factors, also the social science considerations, policy considerations such as social distancing and even investment in emergency equipment. Is that having an impact on the outcomes for the pandemic? And also, we decided to look at understanding the risk factors and relevant factors related to COVID-19 transmission, such as temperature and humidity. For example, do the seasons affect the the transmission of the virus. And remember, we're not so much getting a definitive answer to these questions, but we're providing tools, machine learning and natural language processing tools that will help researchers uncover these questions, these findings themselves. So that was the ask. And if you're familiar with the Kaggle data science competition environment, it's quite a challenging computational environment because you have to develop your solution using a single Kaggle notebook, and which is basically hosted in the cloud with limited memory. So we only have 16 gigabytes of RAM to work with, which is quite a challenge in terms of heavy machine learning. Also, there's a 9-hour limit, which I'm sure you'll appreciate is actually a very short span of time if you're training very comprehensive machine learning models. So essentially, we were faced with a very challenging environment, as were others. And around the world, about 500 different teams entered this competition to try to answer these questions. So our strategy, so how do we do this? Our strategy was, I suppose, one of the strengths of Accenture is that it's such a big company, and it's a very progressive company with very diverse teams, and that allows us to gather lots of ideas from people, and people as well in Accenture have different skill sets, like I mentioned earlier. So we have a kind of, I suppose, an ideation session, you would call it, of brainstorming to see what kind of solutions we could come up with. We also did exploratory research, and we tested multiple approaches. And the approach that we kind of were more successful with was the one shown here in the diagram, where we would ingest all of these scientific papers. And at the time when we actually started the competition, there was about 60,000 research papers to analyze. And by the time we finished, there was about 160,000. So it's a significant task in terms of parsing that information. And then we used an information retrieval component, which I'll talk about later, based on Lucene, Apache Lucene. And then a kind of a novel grammar-based approach that allowed us to basically mine the information that we needed. So the approaches that we tried, so like I said, the strategy was to make sure that we did some exploratory work to see what would work. And one of the things that we tried at the very outset was classic, well, I suppose, more current machine learning approaches. So you might be familiar with libraries such as SciSpacey, which provide language models and models for various tasks such as named entity recognition. So we invested some time in models like that, which did actually eventually give us some interesting results. But we found that the time taken to train machine learning models is quite prohibitive. And I would say as well that, if you're training models, you need to have built up models beforehand, ideally, but if not, you would need to use labeled data. And one of the challenges with the Kaggle competition is that there was no annotated data as such. It was really open-ended. So we found that was a major challenge in terms of training machine learning models. We also had considerations around explainability. So if we're actually getting results for the text mining or natural language processing, there's issues of explainability with neural-based models. So eventually we abandoned that approach for a more traditional approach, I would say. So one, of course, is the typical bag of words approach, and we used for one of the approaches the rank BM25, which is the best match search, which is really based on weighted IDF. So essentially the idea here is that if you have frequently occurring words, such as the word the is likely to appear in many of the documents in the corpus. So, that would give it a lower weighting according to the log ratio there on the screen. However, words like COVID would get a much higher weighting. So it allows us to rank our searches and, produce better results ultimately for the researchers. I mentioned in our pipeline, we also used a search based on Apache Lucene. You're probably quite familiar with that. It uses a inverted index, which basically, when we compile the index, it allows us to quickly pull out relevant results and do things like Boolean searches. So you can see there a diagram of the inverted index. You can see it's quite efficient in terms of accessing search results. I suppose the core part of why we did so well in the competition is that we used basically a rule-based approach, not necessarily a neural-based approach, but in fact a rule-based approach, because given the constraints and also given the challenges, it was actually a very good match. And the work we presented really was based on the work of one of our team members, Javier Sastre, who did his PhD thesis on the use of grammars for text mining. And the basic idea is that we can basically form a grammar which matches the text that best suits the user's query. So in one example, we would be searching, say, for the effects of temperature on the transmission of coronavirus, and we crafted a grammar to do that. And the other benefit of this is that it's quite explainable. The grammar is visible. It's visible through a graphical user interface, and it's quite easy to read and understand the grammar. And the results that we were looking for were quite specific. So we felt they were quite suited to a grammar-based approach as opposed to a neural-based approach. So the results. So overall, we actually won 2 of the challenges. So there was about 20 different challenges. And about 600 teams entered the competition, and we ended up winning 2 of the challenges. One of the challenges that we won was the one on ethical and social science considerations, based on a grammar approach, among other approaches. But essentially, you can see here the grammar that we used was one that would parse the text and would pull out tokens of interest. So what we were looking for really was policy measures that have a significant impact on the societal considerations of COVID-19. So, for example, social distancing would be a phrase that would appear in the text. So, does social distancing have a positive impact or a low impact? And I won't go into the details of that specific grammar, but essentially it allowed the team to pull out the results most relevant, and that was awarded the prize for that particular challenge. And you can see some of the results here where, what's the effect of school or university closing? It was relative to, say, measures such as investing in healthcare. It was perhaps less impactful than in the first instance on investing in healthcare. So it did seem to be able to pull out results and track, results related to policy that were of interest to researchers. So that was one major success that we had. Now, I won't go into the technical details of it because of time limitations, but there's a link here where the notebook can be accessed, and you can walk through the code yourself, and you can actually run the notebook yourself if you wish. And the other prize that we won, second prize in the competition, was one that we did for uncovering factors relevant to the transmission of COVID-19. And that was quite a comprehensive challenge. And we used the test case, I suppose, of temperature and humidity. And we wanted to see, could we extract from the large corpus of documents, does temperature and humidity have an effect on the transmission of COVID-19? So like the other approach, it was based on a grammar. Here's the kind of summary of the pipeline. Was based in the first instance on a Lucene-based search, which essentially narrows down the, I suppose, set of relevant documents. And then once we have a set of relevant documents, we then do more extensive information extraction using the grammar. And then finally, we were able to export the results into a table, which allows researchers to parse and peruse the results in detail. I suppose the key part here was the grammar. Ultimately, we could have actually parsed every document in the whole corpus using the grammar and dispense with the search, but the search made it more efficient in terms of narrowing down the set of documents. So here's just a snippet of the grammar, and essentially it parses and tokenizes the tokenized text to pull out clauses that are relevant. So this is really, I suppose, pulling out causal factors that are relevant to the transmission of COVID-19. So we will put temperature, for example, and we'll basically mine and use synonyms for temperature as well, not just the word temperature, but all its synonyms. and we would mine the corpus, and the grammar here was able to extract both positive and negative impacts of temperature on the transmission of COVID-19. So it's quite readable. If you wish to investigate this in more detail, we have the notebook up on the Kaggle website, and it's extensively documented, and you can actually run the code and see the results yourself. But essentially, all of this work, we produced a table, extensive tables, and here's just a summary of the tables that we produced. And and we also highlighted and annotated the clauses that were relevant. So, for example, each row in this table would be from an academic paper or a research paper. We're also able to rank the results, and it pulls out and highlights the relevant clauses. So, for example, in this particular paper, there's a snippet of text saying that changes in temperatures show no significant correlation with cases, and so forth. You might even see as well that there's some contradictory stuff in there as well. If you log on and view the notebook, you'll see that there are many researchers out there, and often researchers can contradict each other, and there's maybe more subtle factors at play as well in terms of temperature and humidity, for example. There could be confounding factors such as the behavior of people in summertime. They're out in the fresh air. Wintertime they're in. So overall, though, it does provide a summary of all of the research out there on the effect of temperature and humidity on COVID-19. And it's a live notebook, and it can be rerun. The corpus is being updated, and we can just rerun these results and pull out these results at will. And again, this was recognized by the Kaggle competition because we won the prize for this one as well. So just in summary, so the results, we took a kind of an approach, a strategic approach of pulling together teams with different capabilities, and we thought about the challenges and the constraints, and we were able to win 2 of the prizes. It's probably worth saying that another prize winner as well did use a neural approach, but there was a lot of experience on that team on the task beforehand, and I think there was a lot of I suppose advantages for that team in preparing, but nonetheless they won a number of the challenges as well. But however, I think the point is worth making that rule-based approaches and maybe traditional text mining approaches still have a role to play. So very quickly, just lessons and learnings. I think we did manage to win 2 of the prizes. It was a very competitive exercise. We didn't just throw a neural network at it. We tried different approaches. Accenture is a big place, a lot of diverse people and ideas, which helped us. We considered what would actually work, and the real world in this case was the Kaggle cloud-based, which I believe is run on Google Cloud. We had to work within the constraints of those virtual machines, so that was something which I think was useful to consider. We thought carefully and deeply about what the actual challenge was. We found out where we could best have an impact. We didn't overlook traditional rule-based approaches. A lot of people use regular expressions, for example. We went beyond regular expressions with a grammar-based approach. And overall, I think the expertise and the effort on the team got us over the line to get 2 of those prizes. So in summary, I'd like to thank the team around us. So Javier, I mentioned earlier, was one of the key innovators here. His PhD work was very valuable in grammars, and we used that to great effect. So many thanks to Javier. Ali as well helped us with the search, among many others. Too many. So,
thank you, Paul. That was fantastic. It's funny, rules-based approach. Who would have thought it, right?
Yeah.
Because if you talk about rules-based approach, people usually will be referring to how people are pretending to do AI by doing rules-based approach, and they're snake oil merchant.
Yeah.
All the stuff I experience every day.
Yeah. Yeah.
And we're gonna throw a neural net at it.
Yes.
Let me tell you about this neural net we're gonna talk about. And I was like,
Yeah. Yeah.
oh really? Okay.
Yeah.
So that must have I suppose
Yeah.
brought a smile to everybody's face.
Yeah, yeah. I mean, our first approach was to go to the neural net approach. We tried traditional approaches, and ultimately the rule-based approach was one that actually worked really well.
Yeah, it's great. And as I was saying at the start of this talk, we could talk about this for a long time.
Yeah, yeah.
It's such a great topic to actually get involved in as well. I'm sure we'll have some questions at the end. Yizel, you've been very, very patient waiting there for your talk now. So you're in San Francisco at the moment, so you've been up early preparing, which we really appreciate as well. I'll just give a little bit of an overview about your talk. It is supporting online community forums with NLP. Online community forums are spaces for members to share ideas, discuss interests, ask questions, and receive peer-to-peer support on a given topic. Because they're dynamic in nature and rich with context, it can be difficult to keep up to date with what's going on in an online community as both a member and a community manager. In this talk, you'll learn about using NLP to empower community members to engage with each other on new topics and improve the community manager experience. Great, so I'm really looking forward to this. You're presenting now, slides are coming up, which is good. And I am going to log out and let you crack on.
Awesome, thank you. Hi, everyone. Good morning, afternoon, or evening, depending on where you're at. So my name is Yizel Vizcarra, and I am a data scientist at Autodesk. I will be talking about how my team and I support the Autodesk online community by leveraging NLP today. And with that, if you're not familiar with Autodesk, we're a company that builds software for people who make things. The saying is that if you've ever driven a high-performance car, admired a towering skyscraper, used a smartphone, or watched a great film, chances are you've experienced what millions of Autodesk customers are doing with our software. As a result, we're also the hosts of the Autodesk community. The community is a global network of connected product users, including around 300 Autodesk super users known as expert elites, partners, and employees. It holds a knowledge base of customer questions, answers, and discussions. The team powering the Autodesk community is a very small but mighty team focused on connecting members to the expertise they need. Given the team's size and respect to its responsibilities, we've turned to automation to aid community managers with day-to-day tasks in the forums and encourage more of a self-supporting community. So as a result, I am here today to speak to some of the projects that focus on the company-managed online forum that allows community members to find answers, share expertise, and connect with their peers. And you can see one of the examples in the image of this slide where a member asks for help in an AutoCAD focused forum and receives an answer from another AutoCAD user. This response actually had a few other accepted or solutions from other members. And it really provides a forum for discussion between the community members. So that takes me to my first use case, which will be focusing on expanding the support the community receives by empowering and encouraging members to not only absorb community expertise, but also offer their own. And so this is some of the work that my team and myself have kind of put together, which essentially we built a recommendation engine. And the first step for our recommendation problem was understanding what to recommend in our use case. And we wanted to recommend new topics posted to the forums for our top 5 most popular products. If a new question comes in, that recommendation would kind of take it in. And before we recommend something, we also need to understand the context of these incoming topics or questions. And when we do that, we do so using a transfer learning technique, which Branden kind of talked about earlier, to create embeddings of community member topics. And I'll speak to that shortly in a bit. And then thirdly, once we figure out what it is we are doing, we need to identify who will consume this information. And we actually originally intended Community Match, our recommendation engine, to be a space where customers would connect with internal Autodesk experts, but later we had a shift and we wanted to kind of nurture that shared expertise in the community between our community members. So that kind of took us into exploring some of the super users, the rising super users, and consumers of the information, being people that don't constantly post, but really read through these forums and intake all the information to kind of expand their expertise. So earlier, I mentioned we used the transfer learning technique, and now I want to take you into some time to explaining that. In traditional machine learning, and some of you might already be familiar with that, so I'll try to kind of go through this quickly, but typically in traditional machine learning, algorithms are trained to solve some kind of specific task in isolation to other tasks. So in essence, no knowledge is really retained, which can be transferred from one model to another. However, we humans have an inherent ability to transfer our knowledge across different tasks, and we utilize that knowledge that we acquire from one task to solve other similar tasks. The more related the task, the easier it is for us to transfer or cross-utilize our knowledge. For example, if we learn how to program in Java, you can probably learn how to program in Python. Another example is if you learn how to drive a car, you can probably learn how to ride a motorcycle and whatnot. So when we think of transfer learning from a machine learning perspective, newer models leverage knowledge like features or weights from previously trained models. So as seen in this image on this slide to the right. And in our use case, we leverage transfer learning by using FastAI's ULM Fit pre-trained model. So Branden kind of talked a little bit about it. When you kind of get an out-of-the-box pre-trained model, in our case, FastAI's was trained on wiki text of, I believe, 103 million kind of words. And then from there, what my team did is they fine-tuned that language model and with support articles, as well as support cases. And this really allowed it to learn both Autodesk language, but also how customers talk about Autodesk. And then we feed it kind of a historical topic in a given domain. So this is the process for us to get embeddings for our recommendation engine. And once we feed this topic, it goes through the language model, and then we output a series of document vectors. So through these document vectors, we essentially do some type of mapping with who the authors were of the people that we identified. So that takes us back to the employees, the super users, and then the consumers of the information and rising super users that are intaking this information. And then we build some type of ANOI index, and we use this ANOI index in order to construct the index. We create a forest, and each tree is constructed in the following way. We kind of pick how ANOI works. It picks 2 points at random, splits the space into 2 by their hyperplane, and then it continues kind of splitting subspaces recursively until the points associated with a node is small enough. And eventually we'll be kind of leveraging that index in order to do some text similarity between what's coming in the forums. So this kind of takes me to like the preparation and what happens in the back end. And in summary on this slide, we basically have some mapping between the historical or knowledge base from the identified target users, and then we have it tied to some embeddings that they're associated with that we can then query in production. So the production pipeline essentially works with a new topic coming in from a community member, any community member that goes into the forums. And the topic consists of anything from questions or discussion, but essentially it's something new, which is what I really want to highlight. And then it goes through this fine-tuned language model, which we're hosting somewhere in an AWS service. And it essentially pulls kind of an embedding from that, and we get this document vector. Once we get the document vector, we actually use that to query kind of the index from previous topics to the similar topics. So what we're ultimately doing is we're comparing the new topic to the old topic here, and we're trying to identify the kind of the top 10 people or the top 10 most similar historical posts. And since we have previously done some type of mapping between the historical topics, we kind of tie it back to the authors who contributed to that. We also have a list, and we have the ability to retain that list of who these experts are. So when we query this index, we identify like the top 10 users who are most likely to answer these types of questions by comparing the new topic to a previous topic that our audience may have contributed to. And then following that, we move towards some business logic where we just identify like who we want to send it to, maybe time zones and whatnot. So we have some rule-based systems here. And then finally, it's where we let the magic happen, where we send about up to 10 emails, given that we do collect around 10 experts here, and then we send up to 10 emails to relevant experts, and we really try to kind of rank that and prioritize it from expanding to our community. And if like maybe after 12 hours we haven't received a response from the people we've sent it to, we'll kind of reach out to our internal experts and our super users to see if they might be able to leverage that. And this is kind of the end-to-end pipeline of both of what happens in the back end, as well as what happens kind of in production and the end result. So some of the benefits of this program are essentially we get faster answers to our community members. We also drive a lot of engagement, which is really awesome. We particularly empower those who maybe are not posting as much, or maybe might not feel encouraged to fully engage in some of the incoming topics because there are super users or Autodesk experts in the forums. But this was also really a way, after some user research, to really push them to kind of participate a bit more and engage in these community spaces and not just consume that information. So we're going through different iterations. Started off from a pilot with just employees, and then moving towards like using super users, then rising super users, and now exploring the space of using people who are just consumers of that information. And then additionally, it's likely that we're increasing activity from these participants that participate in this community match. And then we're also really encouraging peer-to-peer support, which is ultimately something we want to value and really nurture in these community forums. So that really wraps up what we're doing with the recommendation engine with community match. And now I want to quickly run you through our second and third use cases with one shared goal: to aid community manager functions. And in order for them to fully focus on helping customers, we really wanted to kind of take some niche approaches towards those like maybe tedious tasks or time-consuming tasks that we can help with. And one of those being build some, like, listen in for topics to adapt to customer needs. And this really allows us for valuable customer insights and then some flexible solutions where we can quickly adapt to what they need. Kind of the analogy that Alex O'Connor, who presented in the last NLP meetup, he continues to say, like, having one ear to the ground is really beneficial because it really allows us to take action on what customers are saying. So I'll quickly run you through kind of what that looks like and what we refer to as a listening post. So we did do an integration with Slack, and then we do some type of keyword detection on any incoming posts. So we have some like SNS pushing all new topics in, similar to what we do with Community Match. And then we have some Lambda kind of running through and parsing through that text to identify these keywords. This is an example of the work from home listening post that Alex O'Connor built. And he was essentially trying to, well, let me take a step back. Around the time when things started to shut down around the world due to COVID, he was trying to monitor mentions of keywords that were relevant to how Autodesk was handling or the relationship between their customers and community members with the ongoing kind of pandemic and coronavirus, and we really wanted to support that. So there were some business adjustments being done, but first we wanted to have that ear to the ground and really understand what customers were saying and act quickly on these. As you see, like these were very sensitive topics. Like, people were unfortunately being drastically affected by the pandemic, and we were trying to be as supportive as possible and as quickly as possible. So this allowed us to kind of keep in touch with what was going on between our customers' world, but also take action on our end. And then other use cases that have been supporting that we have been supporting through these types of listening posts have been around supporting the business models teams with licensing changes that are being made. Again, it's a way for us to communicate and really portray that, but also listen in on what customers are saying. And then also helping product teams tune in on what their users were saying so that they could have the appropriate kind of engineering team or experts solve relevant issues, particularly around bugs. And we've continued to expand these integrations with different types of use cases as different teams around the company have different needs. But we really thought this as a very simple way for us to take quick action, gain valuable insights, and really listen in on what customers were saying. So the benefits of these listening posts was allowing some visibility on an interested topic. We were also possibly influencing some business decisions that needed to be made quickly, but also listen in on what our customers are saying. It was fairly low effort, and it really encourages a quick response from Autodesk when it's needed. And I think this pretty much summarizes the benefits of this post, which now takes me to the second the second use case or approach in aiding community managers was essentially to identify non-English topics in English forums. This allows some of our community managers to only have to focus on their designated language forums, and previously they were kind of looking through the English forums themselves or using third-party tools. And we took the solution in-house. Again, we've integrated it with Slack. It's kind of the communication tool we use internally, so it's a quick stop, somewhere to go, and it really allows us to design what the post to our nature. And then we took this opportunity to also leverage an open source tool from Fast Text, and then leverage their language detection library. It was, again, fairly low effort for us to detect the top languages that we support, being Russian, Turkish, German, Spanish, Portuguese, Chinese, and Japanese, and probably soon Arabic. And this is a quick way for us to populate that. Oftentimes we see that when customers post in an English-only forum, a lot of our customers tend to kind of report it as spam, which becomes, it really becomes a frustrating experience for someone who might not necessarily know that they're posting in an English-only forum, because oftentimes like your browser just automatically translates everything. When I was looking into it, and I was like using different browser translation. I didn't know it was an English forum, but I have that knowledge of like knowing what to look for to identify whether it is English or not. And honestly, our customers shouldn't have to know. We if they have a question, they should post it, and then we should kind of figure out where it goes. So this was really a way to identify these posts quickly and have our community managers kind of move those, take action, or really handle these use cases on their own. And the reason we are integrating it with Slack is because, one, it allows us visibility with what's going on constantly, and then two, it's a quick kind of a quick stop for our community managers to go to and leverage that information quickly. And really, like we have the ability to kind of even collect or have this feedback loop of collect whether it was relevant or not in the event that we ever need to collect this data or pull this data that we are sending forward, and then retrain some other models and leverage this data. So it's also a win-win. We get some labeling in it for us, and an ability to retrain some of these models should they need to. Okay, so lastly, and I just want to summarize with the benefits of this language detection. So again, customers don't need to know they posted in the wrong forums, and community members in general. We're leveraging an open source tool, and it is highly low effort. We also prevent English users from reporting non-English posts as spam, and then get customers answers quickly from other community members, and getting customers the right support that they need should they be in the right forum. So that pretty much concludes my presentation. Thank you everyone for listening.
Thank you very much. So we are going to start off with some questions. And who will we start? Paul, for your talk, what was it that led your team to a grammar-based solution? You mentioned technical limitations and available expertise. What else?
Yeah, that's a good question. We used a grammar-based approach on a number of the challenges, and by, I suppose, exploring the data, like there's a lot of very specific phrases used in scientific papers which lend themselves to grammars. You can imagine, for example, if you're designing an application to recognize phone numbers, phone numbers are quite uniform and are quite, detectable using simple, even regular expression-based approaches. So there was a sense that for the particular challenges, there was a kind of suitability, if you like, to the technology. And if you can imagine trying to train a model from scratch or even fine-tune a model to recognize phone numbers, it's a lot more brittle than using a grammar-based approach. So there was, I suppose, a suitability, a fit on the types of data that we were looking for in the papers. And it turns out, the grammar was quite robust anyway, and it was quite flexible. It was able to even consider the context of surrounding words by tuning the grammar, so to speak. So, definitely, there's a role for neural-based approaches. And I saw someone mentioned Haystack there as well. They all have a role, but the amount of training that's required, we felt that the grammar was our best bet for winning those particular tasks in the competition.
Yeah, that's very comprehensive. And just a follow-up question on it. Any general advice on how to support a team that probably have lots of expertise and therefore many different possible approaches to explore?
Yeah, that was, I think, a thing that was difficult, but actually worked well. So in the Accenture, we decided to form multiple teams, and you can imagine Accenture is quite a big place. It's very much, kind of like a campus mentality of different skills and disciplines. So one of my colleagues, Branden, he was tasked with kind of organizing us, would be like herding cats, I suppose, into teams. And from then on, we became kind of self-organized, and we were able to then
Paul, I think we had some gremlins there. I heard up to Branden was very good at organizing, and that's where I lost you.
kind of
Could I recommend taking off your video and let's see, it might improve the connection? So Paul had some connectivity issues. So he's come back. Paul,
Hi.
we were just saying we had some gremlins there, that maybe if we turn off the camera, and I heard up until Branden was very good at organizing teams. I'm not sure what everyone else heard, but maybe worthwhile repeating from there.
Okay, so essentially we had a kind of I suppose one of our managers helped orchestrate teams where thereafter would became self-organizing, and it was really just a matter of kind of almost social networking and sharing ideas, and then those ideas crystallized into solutions. So there was, I suppose, a direction given, and then we were able to self-organize after that.
Thank you, Paul. Yizel, Patrick says, thanks for helping the French community with language detection techniques. And a question just to both of yourself, and I'll ask it to Branden first. Branden, if you were to go back in time and offer advice to your younger self getting into this field, is there any advice you would take now that would give you a better footing, what you did?
That's an interesting one. I actually, I feel like I took a pretty unexpected route into the field. I actually studied my undergraduate in classics and Latin and Greek, and moved towards computational linguistics. And that's really kind of what got me into it. But for me, it was this interest in sort of a bit of the like computational numerical stuff, along with this kind of study into the structure of language. But in terms of getting into the field, I would say that so understanding these models, obviously, or at least in this deep learning field that I'm working in, and in NLP, I think understanding the mechanics of like how these algorithms work is very, very important. Definitely understand, that really is essential. But I think having the ability to engineer and to create things using the tools that are out there is quite possibly even more important. I think that more and more there are these libraries which really have packaged for you pre-trained models so that you don't have to go in and sort of program neurons or layers. What's really important is understanding the whole process of how to verify models, how to integrate that into bigger systems, and how to create something that really works.
And is there an alternative approach for QA besides extractive QA models, which utilize language generation for answer outputs, as in kind of neural translation models?
Yeah, there is actually. So extractive QA is just one of these flavors of question answering. The other one is known as abstractive question answering. So it's really about you ask a question to the system, and the system sort of generates word by word its answer. And this is definitely something that has been worked on, and actually something that has been integrated in a much more fundamental way by a certain modeled by Google known as T5, where it treats every single NLP task as what we call a sequence-to-sequence task. So even if you're doing a classification, even if you're doing translation, even if you're doing NER, the model has to give back the answer by generating one token at a time.
That's great, thank you. And Yizel, anything that you would go back and change on your journey?
Yes, just to iterate something that Branden was saying was knowing how to apply a model or into a real world scenario is just as important as understanding how the model works in the background. And actually, oftentimes you'll find that knowing how to apply something will take you a long way, specifically because you are building for an end user and your customers. So just understanding the value of that, and then particularly for someone like myself who wasn't formally trained in this field, I think I was very focused on trying to internalize or read everything or learn things online through online tutorials. But something that some of my peers kept mentioning to me is that you really need to sit down and practice. And I think it took me a while to really understand that, even though I've been doing it my whole life with the way that we learn. But with machine learning, it does come to a point where you honestly sometimes need to break your head and in understanding or trying to get something to work for you to really internalize what you're learning.
That's really, really helpful. I'd like to say thank you very much to all our speakers today. It was a lot to digest, and I'm sure we'll have follow-up questions that we'll send on to yourself individually too, and we'll share all the notes as well. Thank you very much, and I hope to see you again soon. Thank you. Bye.
Thanks so much for having me.
Thanks, Mark. Bye.